deteriorates in service due to its propensity to absorb moisture. Under certain conditions, this can lead to brake failure. In the absence of suitable equipment to test fluid condition, most manufacturers recommend fluid change at fixed intervals and specify the quality of fluid most suited to their vehicles. Since it is difficult to be certain how long a fluid has been in service, and other problems arise when changing fluid, the function of checking this important safety aspect has largely been ignored. This situation should now change. It is now possible to test the condition of brake fluid quickly and accurately using the new Castrol brake fluid condition tester. And changing of brake fluid can also be accomplished without fuss using the Castrol brake bleed system. The new Castrol brake fluid condition tester is simple to use and can quickly determine whether the brake fluid in a vehicle system is fit for continued use or requires replacement. It is a robust, handheld, portable instrument specifically designed as a service tool for the workshop. The tester is stored in a strong carrying case, the inside of the lid providing any operator with easily understood instructions for use. Usually, there's no need to remove fluid from the vehicle, the test being carried out within the master cylinder reservoir. Operation is simple. The tester is connected to the vehicle battery. Correct polarity is important, and it is confirmed by a full display. The probe of the tester is placed into the fluid within the reservoir, so that the fluid level rests between the two ring indicators. Dipping once or twice will ensure fluid encapsulation within the probe. Pressing the reset button clears the display, ready for testing. Pressing and holding the heater button starts the test, and after a few seconds, the boiling point of the fluid is displayed in degrees centigrade. Should the display indicate a temperature below the minimum wet boiling point of the fluid recommended by the manufacturer, then it should be changed by bleeding the system and replenishing with fresh new fluid. Disconnection of the leads to the battery completes the test sequence, which from beginning to end is accomplished in just a few minutes. Having established that the brake fluid needs changing, we can look at the method employed. Brake bleeding hasn't changed much over the years. It is still a time-consuming, laborious operation for any garage, since it often requires 2 or even 3 mechanics, one to operate the vehicle's foot pedal, another to top up the fluid reservoir, and a third to bleed the brake mechanism. This is an unnecessary waste of manpower for what is really a straightforward job. There is now a solution to this problem. The Castrol brake bleed system needs only 1 mechanic, not 2 or 3. It takes a fraction of the time normally taken by traditional methods. Brakes can be bled in just a few minutes, and it is simplicity itself to operate. Having removed the reservoir cap, make certain that the system's bung and the neck of the reservoir is wiped dry and clean. Now insert the bung fully home in the reservoir and screw tight. As the bung tightens, it mushrooms out into the reservoir to form a secure airtight fit. Now connect up the bleed unit to the reservoir with the snap-on connector. Next, connect the unit's leads to the terminals of the vehicle's battery. That's another advantage of the system. It doesn't require any external power source. Brake bleeding can now commence, so switch on the unit. Note how quickly the hydraulic system of the vehicle is pressurized, and also the fact that the unit cuts off at around 17 psi, or 1.1 bar. This means that it doesn't trigger pressure differential or limiter valves in the vehicle. The system works on a high-volume, low-pressure principle, so it's absolutely safe to use on vehicles with push-in fluid reservoirs. With the machine up to pressure, simply bleed the nipples. It doesn't make any difference in what sequence the nipples are bled. When the job is done, switch off. Vent the system and watch the fluid level drop in the reservoir. Remove the connector when the right level is obtained. There are some notable features of the Castrol brake and clutch bleed system which are worth a closer look. The first big advantage of the system is that it is designed to operate on virtually any type of vehicle. The system is supplied with a full set of adapters and bungs to suit the requirements of the widest range. You simply choose the bung and adapter appropriate to the vehicle being serviced. The system is designed to be fail-safe. For example, what happens if the mechanic inadvertently disconnects the hose from the reservoir whilst the system is under pressure? You might expect brake fluid to be spraying everywhere, but this doesn't happen. As you can see, there is no messy spillage of brake fluid because of the special two-way valve in the connector. To prevent moisture getting into the brake fluid, the system uses an anti-condensation reservoir and pipework. The separator valve should be activated on a regular basis, say once a month or more depending on usage. The system holds 2 litres of brake fluid. If the level drops below half a litre, this green light goes out. What is more, the system will not operate until the brake fluid level is correct. What happens if you encounter a difficult or imperfect fluid reservoir in the vehicle? The answer is simply to use this binding strap, which is supplied with the system. It binds the bung and adapter securely into the reservoir neck. Now you can tackle the problem of when and how to change the brake fluid in a thoroughly professional manner, using the Castrol brake fluid condition tester in conjunction with the Castrol brake bleed system. Road safety and the motorist may now benefit from a new service, brake fluid condition testing.
Ever since man invented the wheel, he's been having accidents. Progress was rapid, but there was still a major problem: stopping. The brake was invented and worked well until vehicles got bigger and faster and heavier. Then things began to hot up. So a brake fluid was introduced and the problem solved. Or was it? As cars and technology became more advanced, people began to take their cars, and more importantly, what makes them stop, for granted. Yet in a recent test survey on brake fluid, over 70% of the cars had fluid that was considered unsafe. A serious situation, which perhaps indicates that the average motorist does not know enough about brake fluids.
Stops the car, operates the brakes.
I think it just keeps the brakes moist so they don't dry up.
I think it transmits the pressure from the pedal to the disc.
No, I haven't got any clue.
No idea.
A motoring organisation spokesman confirms this lack of knowledge.
In my opinion, the public aren't aware of the serious nature of brake failure, and we just don't think they do actually take enough care with their checking of their brakes. The only check that they ever do is a fluid level inspection.
But you see, it's not just the amount of brake fluid which is important, it's whether it functions properly or not. So what is the function of a brake fluid? Every time you depress the brake pedal, pressure is applied to a column of brake fluid. As a fluid is difficult to compress, it's very efficient at transmitting the pressure from your foot to the brakes. Clearly, brake fluid has a vital role to play in the braking system. But what is brake fluid? To find out more, we went to Pangbourne, England, to the research laboratories of one of the world's leading experts, Castrol. The first point about brake fluid is that quality matters. To transmit pressure through the brake system, it must remain liquid. It mustn't boil at the high temperatures generated during heavy braking, nor must it freeze at low temperatures. Brake fluids are categorized according to DOT standards, which gives some guide to performance at both the high and low temperature extremes. The higher the DOT number, the higher the performance. But beware, even fluids with the same DOT classification can vary significantly. Accepted international standards such as DOT are also intended to ensure fluid compatibility with all brake system components. Between the foot pedal and the drum or disc, the brake fluid comes into contact with a wide variety of components made from many different materials. The standards are slow to respond to changes in these materials. A responsible brake fluid manufacturer is alert to the latest developments and creates new in-house test methods to ensure maximum product performance. Take brake hoses, for example. In an emergency stop, fluid pressure in a brake hose can be as high as 1,500 pounds per square inch. This test measures the burst strength of hoses after prolonged exposure to brake fluids. Rubber seals are vital components of any brake system. They control the flow of fluid throughout the system and must also withstand high pressures. It's essential that they retain their strength and elasticity. And this tensometer test is designed to measure these properties. Some seals are wafer thin and are particularly vulnerable to a poorly formulated brake fluid. Not only its effect on strength and elasticity, but also its effect on hardness and swelling is evaluated. The rubber should swell in a carefully controlled range. Too much and the piston seizes. Too little and the fluid leaks past. Seals will also wear rapidly if the brake fluid doesn't keep them adequately lubricated. To simulate the wear effects of a lifetime of motoring, Castrol have developed a 500,000 stroke test. With a poor brake fluid, the deterioration is very apparent. In addition to rubber components, a wide variety of plastics and metals are used in the manufacture of brakes. All of these materials must be protected by the brake fluid. Vehicles that are laid up for long periods are particularly susceptible to corrosion, as any wear debris in the brake system settles and encourages corrosion of the metal surfaces underneath. Although problems like this are not addressed by international standards, Castrol have developed their own special corrosion test to simulate these lay-up conditions. Metal specimens are covered by artificial wear debris and immersed in brake fluid, which has been deliberately contaminated by both water and road salt. But of course, all the tests are not done in the laboratory. Castrol works very closely with component and vehicle manufacturers in the development and evaluation of new fluids. Such collaboration covers the full spectrum of laboratory, rig, and vehicle trials. Many manufacturers take their vehicles to the steep alpine passes as the ultimate test on brake systems. Castrol too, either alone or in conjunction with car manufacturers, use this test site for evaluation of brake fluids. During these long, slow, tortuous descents with the brakes on continuously, temperatures of 600 degrees Celsius have been recorded at the disc. An extreme test, but a necessary one for such a vital fluid. Motor racing provides another extreme environment for brake fluid evaluation and a test bed for new concepts in fluids and engineering. Products proven on today's racing circuits may well be commonplace on tomorrow's cars. So, the simple can of fluid most people take for granted is really a high-quality, high-technology product, the result of extensive research, development and testing. And the obvious conclusion, use a high-quality product. But that's not the end of the story. Remember we mentioned that in surveys, 70% of cars tested were considered unsafe. This is because over a period of time, brake fluid deteriorates. It needs to be changed. How often does the average motorist change his brake fluid?
I've never recommended it to be changed.
Never happened in my life.
I don't.
Never.
I think in connection with brake fluid, they don't realise the implications it has with it being a hygroscopic fluid.
Hygroscopic fluids absorb moisture. To illustrate the extent of water absorption, these jars are placed in a high humidity, high temperature environment. At the end of 24 hours, 2 years normal motoring has been simulated, and the fluid contains about 3.5% water. Water content is crucial. It not only encourages corrosion, but also greatly affects high and low temperature performance. Let's look at high temperature performance. All liquids, when heated up, reach a point where they vaporize. Brake fluid is no different, and the temperature at which vapor bubbles appear is called the vapor lock point. Unlike the fluid, the vapor produced is compressible, so pressure on the brake pedal no longer works the brakes. Water absorption lowers this vapor lock point dramatically. A typical good quality brake fluid may have a vapor lock point of 250 degrees Celsius when new. But after 1 year, this has dropped to 160 degrees Celsius. After 2 years, and more water absorption, the situation is far worse, and the danger point may be just around the corner or on the next hill. But it's not necessary to hurtle down steep hills to heat the brakes to danger point. High temperatures can also be reached simply by urban stop-start driving. Advances in car engineering are increasing the potential for vapor lock problems. Aerodynamic designs increase fuel efficiency but reduce the cooling airflow on brakes. Non-asbestos friction materials reduce health hazards but conduct more heat to the fluid. Another engineering advance, the development of anti-skid braking systems, also places increased stress on brake fluid. This time on the fluid's low temperature performance. Anti-skid systems, now fitted as standard to many modern cars, depend on the fluid's ability to flow freely. In other words, its viscosity. And a fluid's low temperature viscosity can be drastically affected by water absorption. But anti-skid system or not, for efficient braking at low temperatures, it's essential to have a free-flowing fluid. The effect of water absorption has recently been receiving a great deal of media coverage.
Recent research in Germany suggests that an unrecognised but significant cause of car accidents could be contaminated brake fluid. Brake fluid, an alcohol-based mixture, has an unfortunate characteristic. It attracts water.
The importance of using a good quality brake fluid and changing it regularly is recognised by the motor manufacturers, who all recommend that brake fluid be changed regularly. In some countries, motoring organisations are pressing for enforcement of brake fluid control. And the subject is recognised in Japan, where brake fluid changes can only be made by qualified mechanics. Clearly, checking brake fluid levels is important, but not enough. Brake fluid needs to be changed regularly. So, we've seen the potential problems. We've seen the research and development which goes into producing a quality product, and we know how not to become one of the 70%. Have your brake system, including the brake fluid, checked and serviced regularly. Change your brake fluid at least as often as your vehicle manufacturer recommends. Always use a top quality product, and you will stop with safety.